So you will need at least a piece of paper. Well, you'll need your graph paper, I mean, at least a piece of paper. At least graph paper is what I was going to say. Just didn't get out the words correctly. So I'm going to be going back and forth, but graph paper obviously, again, will be helpful to be accurate on your notes. So we will be graphing systems of linear inequalities. So we've graphed linear inequalities before, and we've graphed systems before. So now we're going to graph systems of linear inequalities. So who can tell me what the major differences between a linear equation and a linear inequality when graphing? What's the major differences we can tell? No one remembers the difference? Okay, so it's a great start. Linear equations, just like the assignment we just did, you have slope, you have y-intercept. When you're graphing a inequality, you should have dashed for solid line, and you should also have shading. That is the major differences that you have with inequalities, which was the last lesson that we learned before the last test. So 2 lessons ago. So which inequality signs represent dashed lines versus which inequalities represent solid lines? Equal to is solid. Okay, so greater than and less than are our dashed lines, or dotted, however you want to refer to it. And our greater than or equal or less than or equal are equal to our solid line. Okay, how do we identify shading? How do we test and identify our shading for inequalities? Test points, yes, that is correct. We do test points. And what must be true about the test point? If the signs make it true, yes, so we do need for the signs to be true. But what can a test point not be? Can't be false. No, a test point could be false. Can't be on the line, thank you. So it is any point that is not on the line. Okay, so we had two different scenarios when the test point is true versus when the test point is false. Okay, when a test point is true, what do we do? shade on the side the number is on, correct? Okay, we shade on the side where the test point is. Good. What if the test point is false? We shade on the opposite side. Oh, thank you. We shade on the opposite side. Oh, my words kind of went together there. Shade on the opposite side where the test point is. Okay, good. I'm glad we went through that reminders. That was a little bit rough of a refresher, but we're going to move on. So number 1 is y is greater than negative x plus 5 and y is less than 3x minus 4. So before we get started on graphing these two inequalities, I want to clarify that with inequalities, we don't have one single point that is the answer. Okay, remember, because you're shading, you have a range of answers. So the answer is going to look a little different when we graph the systems together. So just make sure you stay with me and ask questions as necessary. Okay, I fully expect there to be questions. I would much prefer you ask questions now than, during the test. All right, so just rewrote it on here. Okay, so we're going to make 10 by 10s. Okay, again, remember, 10 by 10 is the standard size. I know some of you probably really liked when we did 5 by 5s at first, but that was kind of to get you started to feel more comfortable with it, but keep in mind that a 10 by 10 is standard. So as always, I count down to make sure I don't waste any space. Okay. And when I mean waste space, I mean like if I started counting randomly, I don't know if I'm actually going to make it all the way to the top or if I've left space at the top that I didn't need to have. So by counting down from the top, you can ensure that you have not wasted any space to make sure your graph fits. Okay, and like I told some of you, make sure your graphs do not overlap, okay? Your graphs should not overlap, so if you can stack them directly on top of each other, or if you can alternate them on the corners, that's fine, but they should not be like, you shouldn't have the next graph starting like here, like making a line here, that's overlapping. Okay. I don't need that yet. I'll redraw that later. Okay. So we have my grid. So we're going to start with the first one. So same thing we did with equations. You start with your y-intercept, then you graph your slope. So our y-intercept is 0, 5. Our slope is negative x. So that means negative 1. So that means I go up 1 to the left 1, over and over and over, like such. Then I go the opposite direction and keep the same pattern. Okay, very simply just follow the pattern until I run out of numbers. And then we connect our line. Now remember, we have to think about dashed versus solid. So will this first line be solid or dashed? Will this first line be solid or dashed?
Solid.
It should be solid. So because it is greater than or equal to, then it is solid. And line up your points. That's why we do points all the way across, so we can make sure we have a nice straight line. Ooh. Okay, good. Okay, now from here, we got to do our test point to identify shading. Okay, so I'm going to go back to my lined paper just so that I have a bit more space. Okay. So can I do the test point that we normally use? Can I use 0, 0 to test for this inequality? Yes. Okay. So reminding what test point means, remember we're going to substitute 0 or whatever number you pick in for x and y. So that would mean 0 is greater than -0 plus 5. Okay, well, -0 is not really a thing. So is 0 greater than or equal to 5? True or false?
False.
It is false. Thank you. Good job, Louise. Okay, it is false. So because it is false, okay, that means we're going to shade on the opposite side from where the test point is. So 0, 0 is on the left side, so I'm going to shade on the right side. Now, before you do that, shade lightly, like even lighter than you normally shade, okay? Just enough to where you can tell where you're shading. Very lightly. Do not do harsh shading right now. Please, please, please. You will understand in a second. Please listen to me. Do not shade harshly for this one. Okay, so I just have a nice little scribble. I can tell where my answer is supposed to be. Okay, now we're going to do the exact same thing, but we're going to do it with the second inequality. Okay, so that's why I said shade lightly, because you're going to have to create the second inequality and the line might go through there. So you still need to be able to see the grid. Okay, so we're going to shade, or not shade, we're going to graph the next one. So the next one has a y-intercept of 0, -4, and a slope of 3. So it means I go up 3 to the right 1, up 3 to the right 1, up 1, 2, 3 to the right 1, and so forth. Okay, now what you may have noticed here is that they didn't actually meet at a specific point, and that's okay for inequalities. Okay, they do not have to meet at a specific point for inequalities, like a nice, pretty point. Okay, that's okay. So should this one be dashed or should this one be solid? This one should be dashed. Good. So again, line up your points, and what I've always said is you can basically connect the line for every other dot. So we got, so we have a dashed line. Okay, now we have to complete the testing point again, but for this line, okay? So I'm going to go back to my lined paper to do that. And the reason why I do that is just to kind of keep it clean on the graph paper, okay? Because if you do too much work over here, it kind of muddles up the picture you have. So we're going to go back to the line paper to do the next test point. Now, can I do 0, 0 again for this one? For the second one?
Yeah.
Yeah, we can. Yeah, it's clearly over here on the left side of the line. So yes, we can still use 0, 0. So now we're testing the second one. So is 0 less than 3 times 0 minus 4? Okay, and again, that's why we use 0, 0, because then we're multiplying or adding with 0, which is great. 3 times 0. So is 0 less than -4? Is 0 less than -4? It is false. Good. Okay, so again, so when we shade it, 0, 0 is here. So to shade on the opposite side, I'm shading on the opposite side of this line. That means I would shade everything to the right of the line. Okay, so now we have a graph that looks like this. Okay, so now we're to the point where we get our final answer. So I need everyone to pay attention and let me know if you need more time or need me to answer something before we go further. So let me summarize while I give you a chance. So with inequalities, we do the same thing with y-intercept and slope. Then we have to identify dashed versus solid, and then we have to identify our shading. When we identify our shading, we do our test point, make sure that we know which side should be shaded. Sorry. Ooh. I need some more water. Okay. So now we have shading, and I'm gonna use my ruler to help us. So on my first line, I shaded to the right. For my second line, I shaded to the right as well. So what ends up happening is, can everyone see where both my shadings meet up? Yes. So what we did before was we wanted to find where the lines crossed because we wanted to find the point that matched both statements. So in inequalities, because you're not looking for a specific point, you're looking for a specific section of answers that work for both. If it's shaded in both, then that means it works for both. So my final answer is to essentially what I refer to as make sure you double shade the part that is the final answer. So wherever there's shading for both lines, I'm going to go back through and make a darker shading. So now I can clearly see that answers that would work for both inequalities are going to be in this section that was created from my lines. Okay, and then that's how you identify your final answer for inequalities, for systems of inequalities. Okay, now some students like to do different colors when they do this. I can do that on the next one if you'd like me to, but essentially they'll do like pink for the first one, and then they'll do purple for the second one, and then they're like, oh, where the pink and purple match, that's my final answer, and so then they'll color like the third one in like blue or green or something. So if you want to do colors, that's perfectly fine. I always like when students do color. It's just nice and fun to see. But you can also just do pencil, where you just shade lightly, and then shade darker at the final answer. Okay. So anyone have any questions or concerns for number 1? So essentially, just like the last one with systems of equations, you're doing inequalities twice, and you're finding where they meet up or match up. Any questions or concerns? Okay, let's try number 2 then. Okay, number 2, we have y is greater than negative 6x minus 3, and y is less than or equal to negative 6x plus 4. Okay, so again, number 2, with y is greater than negative 6x minus 3, and y is less than or equal to negative 6x plus 4. So we're going to do that over here on the grid paper. Give me a second, and we're going to all create our grids. We can make our image. Remember, I know it seems like it takes forever, but it really doesn't once you get used to it. And again, your graph should always look like what we did in class together. They should be neat, organized, one number per line. Okay, we will not be doing graphing forever. This unit does do more graphing like the last one. Okay, but I believe this is the last graphing unit we have for this, for algebra. I'm in my brain searching. This should be the last graphing. Not to say that you won't do more graphing, because they'll be graphing on the final, but I believe this is the last unit with graphing. Yes, I'm gonna stick with my answer. I'm gonna stick with that choice of statement. Okay, so we're gonna do number 2. So we start with the first one. Now again, technically it doesn't matter which one you want to start with, but we'll start with the first one. So we start at 0, -3, and we have a slope of -6. 1, 2, 3, 4, 5, 6 to the left 1. 1, 2, 3, 4, 5, 6 to the left 1. And down 6. 1, 2, 3, 4, 5, 6 to the right 1. Okay. Should this first line be dashed or solid? Should be dashed. Okay. Now, when the slope is much more spaced out, it's a little bit harder to do your dashed line. So I normally do lines through those points versus every other point, just because they're so far out. But as long as it's clear that it's dashed, sometimes I'll put lines in between just to make sure that it's clear where the barrier or border is between the two sections, obviously. So now we're going to do our test point. Okay, can I use the test point 0, 0?
Yes.
Yes, I can. So it is very close, but it is on the right side. So is 0 greater than -6 times 0 minus 3? So times 0 goes away. Is 0 greater than -3? Yes, yes it is. That is true. So therefore, we're going to shade on the right side. Again, shading lightly, because we have to graph our next one. Okay. Now my next one, my y-intercept is at 0, 4. Bloop, up here. And we have our slope of -6 again. So we have 1, 2, 3, 4, 5, 6 to the left 1. Down 6. 1, 2, 3, 4, 5, 6 to the right 1. 1, 2, 3, 4, 5, 6 to the right 1. Okay. Should this line be dashed or solid? Should be solid. Good. Now we're ready for a test point again. And I use the point 0, 0 for the second one. Yes, we can. Again, it's very close, but it is clearly on the left side. So is 0 less than or equal to -6 times 0 plus 4? Or in other words, is 0 less than or equal to 4? Yes, it is. Therefore, that is true. Oh, sorry. Luis, what did you say?
No, yeah, that's what I was going to say.
Okay, good. Sorry, didn't mean to cut you off. So therefore, per the second line, this line that we just drew, the solid line, should I be shading to the left or the right? should be shading to the left, right? Because 0, 0's on the left side of that line, so we shade to the left. Okay. Now it kind of looks like the whole thing is shaded, but where does the shading overlap? Where does the shading overlap? Because the first one we shaded to the right, and the second one we shaded to the left. So the shading is overlapped. Where? Okay, so I have some people saying it's parallel, they never meet. That's true, they do never meet. The lines never meet, but where do the shadings meet? So again, the first line I shaded to the, oops, sorry, my pencil came apart. The first line I shaded to the right. My second line I shaded to the left. So therefore, where does it meet up? It meets up in the middle.
Really?
Yup.
How? I thought it wasn't touching.
Well, the lines don't touch, but the shading did. The shading overlapped. So again, using your ruler, you have your first line and you shaded to the right, right? The second line, I shaded to the left. So that little sliver between the two lines had shading from both parts.
Now I see. It's because I was confusing the line.
Yes, that's why I try and use the ruler to help saying like this line versus that line. Okay, so does everyone see how that's in the middle? So yes, they are parallel. Yes, those lines never meet, but their shadings overlap in the middle. Okay, that one is a trickier one. Questions or concerns about that one? Okay, it's okay to have questions. Again, I would much rather you ask questions now than during the test or, you know, later, I guess, even later than that. Okay, so for number 3, I want you guys to try one on your own, okay? So typically in class, that would mean that I would walk around and look at your assignments and see like, hey, are you doing correct? Are you doing it all right? Obviously, that visual aspect of class is not here right now. So what I do want you to do is complete it. If you have questions, let me know throughout the process, okay? And then in the end, for your final answer, obviously it's kind of hard again to show me that you got the correct answer, but we can just see how you go, okay? So if you have questions, you let me know. If you don't, then you'll just know once you see the answer, okay? So, not the most efficient way. I could use the whiteboard method, but I didn't want to do too many things today with like too many programs, like doing graph paper, then doing the online graph paper. So it's a little bit of a difficult task to see how you're doing. Okay, so number 3 that I want you to complete on your own, I'm going to give you 6 minutes, 5 to 6 minutes. So 10:40, we're going to come back together. So number 3 is y is greater than 2x minus 7, and y is less than or equal to negative 3x minus 2. Okay, so I'm going to mute myself, but I'm still here, just so you don't hear me randomly talk. So if you have questions, though, unmute yourself or put in the chat. Complete number 3 on your own. Shading, dashed, all that stuff. Okay, let's try this one together. So hopefully you've completed it by now. That should have been enough time to complete that task. Okay, so I didn't do any of it, so I'm trying to show you how fast you can complete these types of problems. So I'm going to time myself. So I'm going to wait till the top of the minute so that I don't have to really pay attention to the specific second. Okay. Oh, I even started 2 seconds late. Okay, 10, 9, 8, 7, 6. And I hope that this one went well for you. I hope it was easy. I hope that if it wasn't easy, you were able to figure out your own answer because no one asked me any questions. See, my line was a little off, which is giving me a little bit of a double vision here, but it's okay. Whew, just a minute to do the grid alone. That's okay. So 0, -7, slope of 2, so up to the right one, over and over and over again, all the way up and all the way down. Okay, that one should be dashed, like through the snow. We don't have, but you know, dashing through the snow. Okay, so then we do our test point, which I can clearly do 0, 0. So is 0 greater than 2 times 0 minus 7? So is 0 greater than -7? Yes, yes it is. That is true. So therefore I can shade to the left. And I'm going to shade lightly. Okay. Another minute has gone by. Now we're going to go up to 0, oh, -2, not +2. Make sure I write the right one. Slope of -3. So up 1, 2, 3 to the left 1. 1, 2, 3, left 1. 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh, this one actually does meet up. But that's okay. It doesn't really matter if they meet up specifically on a point. This one is solid. Okay, this one is clearly to the side of 0, 0. So I can do test point of 0, 0. So is 0 less than or equal to -3 times 0 minus 2? So 0 less than -2. That is false. Okay, now this is typically where students struggle with their shading. Okay, so this is the line we're working with, so kind of ignore all the other shading. 0, 0 was on the right side, and it was false, so therefore we're going to shade on the left side of my line. Oops. Left side of my line. So therefore, the double shading, so the shading was here originally, and then it became here. So the double shading is this left portion all the way down to here. Okay, so that is the correct answer right there. And that took me 4 minutes while talking. Granted, I do this, I've done this for a living for a very long time, but I'm trying to show you that you can get these things done quickly, okay? They do not have to take an abnormal amount of time, okay? So how did we do on number 3? Did we do good? Did we make a mistake? Do we know what our mistake is? I would love to see information from everyone that's in the chat. So far I have 1 response. Okay, so let me repeat myself. I would love to see everyone's response in the chat of how number 3 went. Did it go good? Do you need to fix something? Got it right? Yeah, good, right. You know, those are same word for me. Oh, look, we lost more people since I asked that question. I don't know if it's internet or what's going on. Okay, everyone that responded said good, which doesn't necessarily mean everyone that didn't respond is good as well. It just could mean a lot of different things. So I'm not necessarily going to assume anything, but if you're not responding, I don't know if you're actually participating. Okay, let's try number 4. Okay, number 4, I'm gonna make you work for it a little bit more because you're gonna have to rearrange equations on the, or rearrange inequalities on this one. So 2x minus 3y is greater than 9, and 2x minus 3y plus 12 is less than or equal to 0. Okay, so first thing you need to do for number 4 is rearrange so that they are both y by themselves. Everyone should be rearranging this task. Okay, let's see how that looks. So when you rearrange these, I'm going to subtract the 2x to the left, or sorry, to the right. Divide by -3. Okay, because I divided by a negative with an equality, that means now I have y is less than 2/3 x minus 3 for my first one. Okay, for my second one, I'm going to go ahead and add 3y to the right side. Divide by 3. So I get 2/3 x plus 4 is less than or equal to y. Okay, if I rewrite this, that means the sign has to change. Okay, I didn't flip the sign, I only changed how it was written, so therefore the sign does have to change. Okay, so for number 4, you need to graph these two. Okay, so go ahead and complete number 4 for graphing. Okay, and then we'll catch up again together to see how we did. So those that made mistakes on the last one can fix them, and those that did well will hopefully continue that pattern of success. Again, I'm here if you have questions, but if not, I'm going to give you 5 more minutes to complete that problem. Okay, so I did it in 5 minutes, you can do it in 5 minutes, I promise. Okay, let's see how that one went for you as well. Okay, again, I'm going to complete it live so you can see that I'm not doing any fancy trick to get it done myself. It just requires a bit of time to complete each problem. So we'll obviously first start with your grid. Remember, they should not be overlapping, especially with inequalities, because obviously you're doing shading, so shading cannot overlap on itself. I think I messed up on my numbers. I think this should have been, it's okay. I won't get to I skipped a line on accident, so I'm gonna have to stop at -9. Oops. Okay, so I'm going to start with the first one, 0, -3, slope of 2/3, 1, 2 over 3, slope 2, right 3, down to left 3, down to left 3, over and over. Now this one should be dashed or dotted, doesn't matter how you refer to it. Okay, clearly to the left or right of 0, 0. So my test point is 0, 0. So is 0 less than 2/3 times 0 minus 3? So is 0 less than -3, which is false. Okay, so therefore I'm going to shade to the right of my line. I don't know why, that kind of was weird. Okay, now I'm going to do my second one. 0, 4, slope is 2/3. This one is solid. Okay, 0, 0 is clearly on one side of the line, so I can test 0, 0. So 0 greater than 2/3 times 0 plus 4, or is 0 greater than 4, which is again false. So therefore I shade on the opposite side. Okay. So in this case scenario, because of shading, there is no overlapping. So this would be your final answer. So this is a scenario where your parallel lines don't match and your shading don't connect. So therefore this would be your final answer, which would be a no solution type of answer. There's no number that both, there's no coordinate point that would work for both inequalities. So that would be how it looks for number 4. Okay, questions or concerns? How are we feeling about this material, this concept? Okay, well that is